Okay, we're back with section 1.6. I went ahead and finished drawing this figure in. We're going to look at 20 through 23. They're asking me to look at this figure and tell the measure of each of these angles. So some of this we've already sort of talked through. We said in number 17 that angle EOA was supplementary to angle EOC. And since EOA is 90 degrees, that means that EOC also has to be 90 degrees. Okay, angle DOC is here, and we said that it was complementary to angle EOD. Those two had to add up to 90, and they tell me that angle EOD is 60. So that means that angle DOC has to be 30 degrees. Okay, now we need to find angle BOC, which is this larger angle here, and angle AOB. It's actually easier to find AOB first. If I look at the figure, the angle DOC and angle AOB are vertical angles, and remember that vertical angles are congruent. So if DOC is 30 degrees, then the vertical angle AOB also has to be 30 degrees. And then finally, now that I know AOB, I can find angle BOC. If I put AOB and BOC together, they make a straight line. They're supplementary, which means they are 180 degrees together. So 30 degrees subtracted from 180 would give me this angle, which turns out to be 150 degrees. Okay. Okay, and the last problem in this section is number 43. I drew the figure here. They gave me some information. They asked me to find the value of the variable, or to find x. So I have this picture where they did mark the angle AOB and angle COD as being congruent. Those two things are the same. So I know that I can find AOB and COD by setting them equal to each other. Okay, let me erase so I have room. So I'm going to say 4x minus 2 equals 2x plus 14. Okay, so if I solve for x here, I would subtract 2x from both sides. It would leave me with 2x minus 2 equals 14, and then I would add 2 to both sides. So I'll get 2x equals 16, so x is equal to 8. Okay, so I didn't even really have to use measure of angle BOC to find what x was. Let me see if they did want me to find the angle measures after I found x. So for angle AOB, I would plug in 8 into 4 times 8 minus 2, which would give me 32 minus 2, which would be 30. So that's this angle here. Now, according to the diagram, COD should also be 30, but I'm going to double check. If I plug this into COD, it would be 2 times 8 plus 14. That's 16 plus 14, which is 30. If those didn't come out the same, I know I made a mistake somewhere. Okay, and then the last one that I don't know is measure of angle BOC. It was 5x plus 10, so I'm going to plug in 5 times 8 plus 10. That will be 40 plus 10, which is 50. Okay. All right, so that's all from section 1.6. Let's look at, I'm going to skip over section 1.7 because it's the constructions, and I'm going to go to 1.8. Okay, 1.8, number 26 is the one that I had listed in here. Let's see what that was. Okay, this is the one where, this is where we were using the distance formula and the midpoint formula. And they've given me the coordinates of a midpoint and then one of the endpoints, and they need me to find the other endpoint. So let me write down each of those. So the midpoint that was given has coordinates 5, negative 8. Okay, that's the midpoint of the line segment ST. They gave me the value, the coordinates for the point T. And it is 5, -15. And they want me to find the coordinates of S. So I'm just going to call that X and Y. We don't know what that is yet, but they want me to find each of those coordinates. So what I'm going to do is I'm going to use the midpoint formula. The midpoint formula was x1 plus x2 over 2 for the x coordinate, and y1 plus y2 over 2 for the y coordinate. I know one x value. I don't know the other one, but I'm just going to fill it in. So I'm going to put 5 for the x value from t, and then I'm just going to use the x that I put in here for s. So it's 5 plus x over 2. That's going to be the x coordinate of the midpoint. And then the y coordinate will be -15 from t plus y, we don't know yet, from s over 2. So this is, using my midpoint formula, this is what I would get. But I actually know what that value turns out to be. So what I'm going to do is solve two different equations, one for x and one for y. I'm going to set the equation that includes x equal to the x value from the midpoint that was given. So I'll have 5 plus x over 2 equals 5. All right, and then I need to solve that. So if I want to get rid of the 2 down here, I need to multiply both sides by 2. That will cancel on the left side and leave me with 5 plus x equals 10. And then I'll subtract 5 from both sides and I'll get x equals 5. So according to this, the value of the x coordinate for s is 5. And now if I want to find y, I'm going to do the same thing. I'm going to take what my midpoint formula said that coordinate would be, and I'm going to set it equal to what the problem told me that coordinate was. So it'll be -15 plus y over 2 equals -8. And again, to get rid of the 2, I'm going to multiply both sides by 2 so that it cancels on the left. I have -15 plus y equals -16. And then I add 15 to the other side, or both sides. So I get y equals -1. Be careful with your signs there. It's -16 plus 15. So y is -1. So the coordinates for s then would be 5 for the x coordinate, -1 for the y coordinate. Okay, so this is how you do it when you know one endpoint and you know the midpoint, but you're trying to find the other endpoint. Okay, that was all for 1.8. Let's go to 1.9. Find it. Number 37 was the first one I chose. It's the area of a shaded region that's not a regular shape. So, let's draw it up here. Okay, in this case, the whole thing is shaded in. It's just an irregular shape. So they've got some things labeled. This is 10 meters. From here to here is 5 meters. And this measurement is 5 meters. It's 20 meters all the way across the top, and then 18 meters along this side. So we have to split this up into some figures that we know how to find the area of. So my suggestion would be to split it up where this red line is on each side, find the area of each of the small pieces, and then the large piece. So for the large piece, it's going to be a little easier. When I cut this little bit off, then this part that's left on the inside is going to end up being 13 meters there, because the whole side has to be 18. So 13 times 20 will be 260 meters squared. That's the large part. It's not writing. And then I just need to find each of these pieces. So we know this piece is 5 meters. In the middle it's 10, so that's 15, but it's supposed to all be 20 all the way across, so this must also be 5. And this too. So each of these are squares that have the side of 5. So each of those little pieces would be 25. And so the area of the whole figure, I would just add those all up. So I would add up 260 plus 25 plus 25. So that's going to end up being 310 meters squared for the area of that figure. Okay, let's look at the next one. Number 47. Okay, this one, they give me the area and they tell me how wide a rectangle is, but then they're asking for the length. So this one, the area is 176 centimeters squared. And this is of a rectangle that has width 11. Trying to make sure to say it wrong. Okay. I'm looking for the length. So the area has to be the length times the width. So I know that it's 11 times the length. And that has to be equal to what they told me the area was, 176. So all I need to do is divide by 11. So let's see, what would that be? It would be 16, I think. So, yeah, so it's 16. The length should be 16. And that's in meters. So if you're given the area and not one of the sides, then you just need to fill in what you know and solve for that one that you don't know. Okay, the last one from this section is number 53. So I'm supposed to draw a rectangle and then find its perimeter and area. So let's draw this in. Okay, I have the, oh, it's not good. I'm going to try to draw decent. Let me do it this way. Okay, so they tell me that A is -3.2. That's here. B is -2.2. C is -2, -2. And D is -3, -2. Now on this one we turned out lucky because all of these are vertical or horizontal lines, which means I'm really just counting the spaces up or down or left or right, depending on which line I'm looking at. If it were not a horizontal line, we would need to use a distance formula. So, but for this one, the distance from A to B is just one space when I go horizontally. And the same for C to D. And then up and down when I'm looking from B to C, it's 1, 2, 3, 4 spaces, and the same thing from A to D. So they wanted the area and the perimeter. The perimeter would just be 2 times 4 plus 2 times 1. So that'll be 8 plus 2, which is 10. And then the area will just be the base times the height. So that would be 1 times 4, which is 4. So this would be 10 units. This would be 4 units squared because we did area. And that's the end of that section.